And welcome back. This is a video inspired by Big Clive and his light bulb series. This is a Tesco brand 48 milliamp 6 watt. Now there's a light on our landing that comes on at night and stays on all night, and the channel master, the other half, thinks that the light bulb is too bright. It's only about a 4 watt. So my idea was go to Tesco's, buy one of these bulbs, and if it's the same as Big Clive's, change the resistors and make it something like a ½ watt. So just enough light to see by and not enough light to annoy the wife during the night. As you can see, you probably can't, you can't see loads of bits of damage around here, but I haven't got a spudger, so trusty screwdriver, and we'll kind of go around and loosen it off. Sticking it in and waggling it. And it went click. Nope, it's rotating, but it's not come loose. So, there we go. Right, we're zoomed in, and we have, looking at this, a big capacitor stuck in the top, bridge rectifier, 4 resistors of the same value, the bright power chip, 2 resistors that are, I assume, are across the capacitor, we'll check that out, and 2 low value resistors down in there in parallel. Yeah, you can see the main chip, the bright power. I think it's a 51331J, because if you rotate it slightly, a 1 appears. So I think that's the part number. We have 62 ohms and two 62 ohm resistors in parallel there, and over here we have some 4K7s, not sure if they're all in parallel or not, but the circuit I'm hoping will be the same as Big Clive's. It only has, I'll turn the microscope off, it only has 5 LEDs, so they're probably overdriven, but the idea is to try and remove those 2 resistors and see what it cuts the current consumption by. So if we have a quick look, trusty meter in, and some leads, oh, they're all tangled up. Can't beat tangled up leads. There. .31 ohms. Yeah, so 2 62s in parallel there. I'm just going to pause and put up the data sheet. Right, quick look at the bright power data sheet for the BP5131D, as the 31J didn't have much information in it. But here we have the same circuit. Basically, it's just a current regulator. So measures the current across your resistor and limits the current through itself to that value. So quite a simple design, but being linear, it does mean that of course the higher the current flow, the hotter it will get, and there are limits to how hot it can go. Now there's the pinouts. the drain for the LED strings, the ground, and the current sense. So quite a simple chip. And so the resistor for sensing is just between those two pins. A couple of absolute limits, not really worried about them. And this is the one important one, VREF, which is 600 millivolts. So that's what the chip is aiming to do. It's aiming to supply current until that CS, the voltage across the RCS, is 600 milliamps, and that's it. So whatever value you set, the current will adjust until the voltage across the resistor is 600. So quick, that's about what it does. So not a great deal to worry about. There's the formula for working out the current. 600 milliamps divided by your value. But the important thing to remember is if your current is too high, your chip will get too hot. Right, let's see if we can get the resistors off. No, not going to work. As Big Clive said, they put up a fight. So giving it a good old clean. There we go. I think those can be considered clean enough to put new components on. Good enough? Possibly. Now, do I fit a single resistor or two? I think I'm going to fit a single 200 ohms, or maybe two 400 and somethings. Right, try and put 430 ohm resistors on. I forget to do a lot of talking in this bit while I'm trying to put the resistors on, as it was a little bit fiddly. So please hum along to your favourite tune while watching, and I'll come back when I've got something else more interesting to talk about. Solder my soldering iron. Dab that there, make it. It's a bad joint, but it will do to hold it in place. Have a solder on there. Not the best soldering job, as the substrate's wicking the aluminium is wicking the heat away very fast. I have to do a bit of tidy up job on that. That's alright. Get it clean. What I'm going to do here is I'm just going to measure across the two resistors to make sure that they are both connected, and I see half of the 430 ohms. There. 215 ohms. And then I'm going to measure between other points on the IC to make sure that the ends of the resistor are still connected to the correct places on the chip. There's no broken pads while I've been mucking about with it. Well, it's making connections to the right places on the chip, so job must be okay. Next time we'll turn it on and see what happens. Putting it back is just a simple matter of pushing it in, and it does put up quite a fight to come out. So at this point I'm not even going to bother gluing it. Right, let's go and try it in a lamp. This is a 4-watt bulb. As you can see, the camera's having problems looking at the brightness of it, but it's bright, very bright at the top. This is the bulb after being modified. As you can see, it's an even spread across the lampshade because the camera's not having so much problems with the dimmer light. But there we go. If you'd like to subscribe, click on the subscribe button, hit the bell, and I'll catch you on the next one. Thank you for watching.